All right. Well, good afternoon, and thank you so much for your time this afternoon and joining us for our webinar focused on From Chaos to Order, the cross-cutting concept of patterns. Before we jump into the work today, just a few reminders and housekeeping items. First, this is our statement about the use of artificial intelligence during meetings like this. I'm not going to read it to you. The big point is we ask that you don't use those AI note catchers or note takers. That's because Teams treats them as a person. And so when we use functions like breakout rooms, it will assign them to breakout rooms like people. And one time during a webinar, we had somebody stuck in a breakout room with only AI note takers. So they had no one to talk to or interact with because it was just AI in there. So if we do see them in the participant list, we will be kicking them out just for ease of use for everybody across the webinar this afternoon. And if you haven't met me before, I want to take a moment to introduce myself. My name is Lark Widener. I'm your Secondary Science Education Associate on the standard side here at the department. I am a former high school science teacher, and I'll hand it off to Brent so he can do a brief introduction of himself too.
Good afternoon, everybody. My name is Brent White. I'm your Elementary Science Education Associate here at the State Department. And here we consider that K through 5 in South Carolina. And I will be the co-pilot for today, so I will be dropping links in the chat, and handling any technical issues.
And we really appreciate those of y'all checking in from around the state in the chat. It's really nice to hear from y'all. Sorry we have to disable cameras for webinar functionality, and we look forward to working with representation from across the state in a lot of our different districts today. Now, here's the big thing, right? Like, how do I get my recertification credit? Because we are excited to announce that we are offering 1 hour of recertification credit for today's webinar. So there are 3 requirements you have to meet. The first is you have to attend live and participate in the webinar, right? So there'll be times we've got to ask for you to add information to the chat, give a reaction for somebody who shared, or send y'all to breakout rooms for some collaboration time. The second piece is you have to stay in here the whole time. So you got to stay in the webinar the whole time to earn 1 hour. And then the final part will come at the end when it's time to complete the attendance and feedback form. That is how we will generate your certificate with your renewal hour on it. And our final piece of housekeeping are some webinar norms and some Teams functionality we always like to point out. So if you look at the very top of your screen, you will see a toolbar. I haven't included the entire toolbar, just the parts that are important to our work today. So the first is the little chat bubble. This is where you can access the meeting chat, and I see a lot of people have already gotten there this afternoon. We will ask for interaction in the chat in addition to the opportunity to unmute and share with your colleagues from across the state. When it comes time to unmute and share, it's easiest for us if you raise your hand. That's because we can only see the initials of everybody in the little bubbles at the top, and so we can't see names. So we'll often call you by the initials, and we'll try to stick with the order of the hands raised. Finally, we might ask you to offer a reaction in the meeting to support a colleague who's been brave enough to share and unmute. And so if we can practice really quick, can y'all give me a react right here so that we know how to find the react button? It has lots of options. All right. I think we can confidently say we can find the react button. I will say that cameras are disabled for the meeting. That is to help with the sort of flow of data and the ability to record the webinar. However, you can unmute yourself to talk. When we transition between breakout rooms, though, Brent will mute everybody as we come back in, and we ask that you remain muted unless we are asking for verbal participation in the meeting. And a newer feature for Teams is down at the very bottom, you'll see 3 dots that say, if you hover over them, it says more actions. Just a cool feature. You can adjust how you're viewing the slides, so you can make them even a darker background with lighter text if that helps you view the information, or even translate them into other languages, which I think is pretty cool. A final note is I know sometimes we have issues with accessing the chat or seeing the slides after we return from breakout rooms. The best way to fix that is going to be to leave and rejoin the meeting. There's not really a whole lot we can do on our end about getting you access back to the chat. It's just a bug in the system currently. All right, any questions or clarification about sort of the functionality of Teams before we really jump into the work for today? All right, well, we're going to do a quick activity about choosing your lens. So Brent is going to drop a link in the chat. That will be a force copy Google Doc link. If you can't get it to copy, that is okay. We will also try to get you a screenshot of that in the chat so you can see what we're asking you to do. When you open up this Google Doc, you're going to have two lenses. So I just want you to pick one through which to observe our phenomenon. I'm going to play the video twice. It moves a little fast. The first time I want you to just observe. The second time is when you're going to start thinking through the lens you've chosen. So when you open up and make your copy of the document, you'll see there's two hand lenses with different questions in them. So I want you to pick your lens for observing and thinking about this phenomenon. I'm going to purposely turn the sound off, and we will not watch the entire video. All right, I know that was fast. So I'm going to give you a moment to think. Another moment also to grab your copy of the note catcher in the chat if you need to. Now, using your lens that you've chosen, I want you to observe this phenomenon and then answer or address the question for your lens. I'm just giving you some thinking time to think about how you want to respond through your lens to our phenomenon. And now to share our thinking with the whole group, we're going to use the launch protocol. I'm going to ask you to head to the chat. I want you to type your response to your prompt in the chat, but do not press enter yet. Brett, it's okay. So type your response, but don't press enter until I give the countdown to launch our thought rockets. So type in your response through your lens, but don't press enter. And if you're still typing, that's okay. I'm going to start our launch countdown in 5, 4, 3, 2, 1. Let's launch our thought rockets into orbit. And now I'd like you to take a moment to scroll back through and give a colleague a reaction to their thought rocket. All right, and now I want you to head back to your note catcher, and if you didn't, take a scroll down, and it'll tell you if your lens was an elementary lens or a secondary lens. So today we're really going to be focusing in on how do we help students use patterns in the classroom. And so for our agenda today, we're going to take a look at our learning targets. We're going to do a quick mini lesson on patterns as they relate to the cross-cutting concepts for our 2021 science standards. We're going to have some time to do a document dig into some resources to support the use of patterns in the classroom. Circle back for some clarity and closure, get that attendance and feedback done for your credit, and then we have some time for some pre-submitted questions from the registration form. So we're going to take a look at analyzing how the concept of patterns supports student sense making in their K-12 science learning experience, evaluating some strategies for helping students evaluate and describe patterns that lead to meaningful investigations, and apply tools to support student growth using patterns across their K-12 science learning experience. And so with that, we're going to hop into our mini lesson. So how do we support students understanding and using patterns? So summarizing from page 87 in the framework, we sort of look at this as our guiding principle for the cross-cutting concept of patterns. Human beings are good at recognizing patterns, and indeed young children begin to recognize patterns in their own lives well before coming to school. Once they are students, it's important for them to develop ways to recognize, classify, and record patterns in the phenomena they observe. So it's really building on this foundational understanding of humans overall are pretty good at recognizing patterns, and we can use that recognition to help us figure out things about the world around us. In a moment, you're going to be sent to your first breakout room experience. You don't have to make a copy. You're just looking at a document and you have some guiding questions. So you're going to read the vertical articulation and use the provided discussion questions to guide your group discussion. And all we're asking is that you're prepared to share a summary of your discussion when you return. So while looking through that vertical articulation of patterns, we want you to sort of talk about what's one insight or surprise you notice in the progression. How does the complexity increase across grade bands? And what implications does this have for your instruction or planning? And we just ask that after your breakout room time, you're prepared to share some takeaways in the main meeting, either through the chat or we'll ask for some groups to unmute and share as well. So Brent has dropped the link in the chat. You're not editing, you're just reading this document, which is why you have view-only access. Any questions for the good of the group before we send you to your breakout rooms? All right, well, we're going to go ahead and send you on to your breakout rooms. Brett and I will be available and hop in and out for support. And we'll probably come back together, let's say we'll do a check-in in about 7 minutes. And just as a reminder, if you're coming back to the main meeting room and you can't get to the slides or the chat, it might be easiest for you to leave the meeting and Brent can help you get right back in. But I'm going to ask for 3 breakout rooms to volunteer and share a takeaway, an insight, a summary of your conversation around the vertical articulation for patterns. So I'd like 3 breakout rooms to share. All right, and I see one hand up for AC.
Hi, this is Angela Canty, and we were talking about how the patterns increase in complexity as it goes. So you start off with an observation, and then you turn that observation into a prediction, and then from a prediction, you're going into somewhat of a small investigation and using graphs and charts from the 6th to the 8th grade. And then when you get to 9th grade in secondary, you have a full investigation with that it provides evidence of what's going on with that pattern observation for students at that level.
Great. Thank you so much for sharing, Angela. And can we give Angela a reaction in the meeting for being our first brave participant? All right. I see EV up. Oh, and now I see JC. All right. Or I see W. If you're ready to unmute and share, it might be Williston.
And while we're working on that, Lark, Jennifer in the chat said that we discussed how patterns started macro and moved to micro. We also discussed the issues that we see with high school students and graphene.
All right, so some recognition of we're going from really easily observable patterns to the underlying mechanisms of those patterns. Thank you so much, Jennifer, for sharing in the chat. Looking for one more, either to unmute and share or share in the chat. We got a KH.
Sorry. One of the things that I mentioned in my group was that, well, we had the progression going, elementary up through high school. This pattern recognition, and that you talk about it in the vertical integration, also works in math studies as far as learning the observations, but also learning, right, how to define them. They may not know the exact name of sequences or that kind of stuff, but learning how to describe them both verbally and arithmetically as they progress through the grade levels.
Great, thanks. So you saw a connection to math and the idea that patterns are a huge part of math instruction as well, even down to how we represent patterns in math, and then we can apply that and use that in science.
Yes.
Thank you. All right, and we've got one more in the chat from Nicola. We shared that there are many patterns in the development and understanding of the periodic table, and I think there is an opportunity to facilitate students in investigating those patterns and arriving at them through investigation rather than telling them.
And we had one more as well in the chat from Brett, guided inquiry to autonomous inquiry.
Great, thanks. And so there are some key things we wanted to make sure to point out about the use of patterns, particularly related to how scientists and engineers use patterns in their work. So generally, scientists are using patterns are looking for those explanations for observed patterns and for the similarities and differences within them, right? That's how we get to our explanations of the world. Engineers spend a lot of time looking for and analyzing patterns as well. They particularly use patterns of design failure to improve design function, and they use them in systems so that they can best meet fluctuating needs of that system. So more of the application of this understanding of patterns in terms of solving problems, not figuring out how the world around us works. But they are both going to consistently represent data to facilitate pattern recognition. And these often lead to mathematical representations of those patterns, especially as we move into sort of higher level thinking with our secondary students. So how do we support students in using patterns? So we got to develop their ability to identify and articulate patterns across disciplines. So for example, we're going to need to consistently highlight patterns in various contexts within life science, physical science, and earth and space science to help students understand that patterns are the fundamental way that scientists are going to classify information, make sense of phenomena. So scientists use patterns and a variety of patterns and different levels of patterns, and that's how they support making sense of phenomena from the very first get-go. When we're analyzing data, we're looking for patterns we can use to explain the story the data is telling us. So by explicitly referencing patterns in multiple disciplines, the hope is students begin to use them as a tool for organizing knowledge and making predictions. So we want to be explicit in our use of patterns across the disciplines of science, in addition to showing how those patterns make connections between the disciplines of science. Patterns often lead to questions about relationships and causes. And I think y'all saw that in some of your discussion of the vertical articulation of patterns. You start seeing cause and effect and relationships come in a lot as we articulate higher in the grade bands. So we want to encourage students to observe and describe patterns in data, phenomena, models, etc. And then we want to guide students to ask questions like, why does this pattern occur? What might be causing it? Will this pattern continue or change? This is going to support a deeper scientific reasoning and help students connect patterns to mechanisms and explanations. Particularly getting at questioning using a pattern is what's going to help guide students towards that underlying mechanism, that thing we can't see, but we can observe through patterns at the macroscopic scale. Like the periodic table example, I think that one they shared in the chat is a really great example of that. And finally, their understanding of patterns evolves over time. And so we need to scaffold instruction by using grade-aligned opportunities to identify, analyze, and use patterns. So let's do a quick check-in in the chat. Looking at these two activities, I want you to order them for complexity. So put the less complex activity number first and the second one second. So move from less to more complexity and tell me why. What's your reasoning for identifying them in that order? So take a moment to review these two activities that students might do in the classroom and tell me which one, give me an order of complexity from less complex to more complex and why. So activity 1 is students mix baking soda and vinegar at different temperatures or concentrations. They measure the time it takes for the reaction to complete and they graph the data. Activity 2 is students place a stick in the ground and record shadow length at different times of day. They graph the data. Yep, so they are right here on the slide, and if you can't see the slide for some reason, I just read them. So activity 1 is mixing baking soda and vinegar at different temperatures or concentrations. They measure the time it takes for the reaction to complete and graph the data. Activity 2 is students place a stick in the ground and record shadow length at different times of day. They graph the data. All right, and we've got some answers coming in the chat. We're looking pretty consistent on activity 2. And then activity 1, with activity 1 being more complex. All right, so we've got some activity 1 is more complex because you have more variables changing. Activity 2 is observation, while activity 1 is actually doing something, carrying out an experiment. Activity 1 is more complex because it requires extra steps of controlling temperature. We've got multiple variables. 2 is recording a phenomenon that's entered, but activity 1 is introducing independent and dependent variables. But activity 2 requires interpreting a pattern.
And activity 1 has a lot more action going on.
A lot more action going on. But the idea here is we should see a progression in the use of patterns by students from simple observations to more complex tasks, including up to statistical analysis, right? So once again, sort of bringing in that discussion about how this is really a great place to look for how we're doing patterns in math, because that's going to be how we represent and analyze really complex, large patterns, is we're going to use mathematical models and tools, right? So we're looking for that progression, though. And that progression should be happening K through 12. And that progression might also happen across the school year, right? So the patterns we're looking at might be a little more simple at the beginning of the course, but we want to progress them to more complex patterns as we continue through our work with students. And now we're going to jump into our document dig. So we've done our little mini lesson. We've engaged with a phenomenon that I'm not going to give you the answer to today, but that was a Newton's cradle. And now we're going to take a look at what are some of the things we have to support using patterns in science classrooms in South Carolina. We're going to use the protocol zoom in, zoom out. So when you get into your breakout room, you're going to dig into 2 resources that support patterns. Your room is going to be assigned elementary or secondary resources to dig into. But if you wind up in a room that doesn't have your grade band's resources, that's okay, because there's a mirror for your grade band. So for example, if you're a high school teacher and you wind up in a room looking at 3-5 resources, just remember there is a mirror resource for high school or middle school and secondary as well. All right. And know that they're all going to be structured the same. So you're going to zoom in and zoom out. So you're going to take independent time to zoom in. And then when you zoom out, you're going to see some discussion questions. All right, welcome back. So I'm going to ask for 2 to 3 of our groups to either unmute and share, or you can add to the chat and I can read out loud for us. What's a takeaway you have from your document dig? All right, so in the chat, Angela shared that students are sorting out information to be placed in the graphic organizer. That information can be written or in picture form. It allows them to make connections to written text and express themselves. We know that writing helps the brain to clarify thoughts, helps them to analyze, and engineering design as well. Looking for at least one more brave unmute and share or contribution to the chat. We talked about how patterns need to be everywhere and not just in math, especially in elementary school. Graphic organizers are helpful for students, and the teacher graphic organizers are helpful for teachers to help them sort of unpack what's being asked of them. And we like the visual representation guides and the independent area to express ideas. All right, well, in getting to some of this idea, let's head to the chat for a waterfall protocol to complete this clarity and closure sentence. Love the question prompts. The three important ideas or things from today are blank, blank, and blank. And the most important thing today is blank. So in the chat, let's type in but not hit enter yet. what are your top 3 things from today and the most important thing from today? It's just a quick summary of our learning. And while we're talking, Sarah shared about sort of categories and if that's definitive, and what if there are no categories in the phenomena that we are observing? Yeah, and so the graphic organizer may not work for every pattern, right? But we were trying to sort of present a scaffold or something that we could use to help students with patterns in that grade band. So it may not be just, it may not work every time, right? We can't use the same graphic organizer every time, but it's an example of a way you could approach patterns and a support for that. All right, and let's go ahead and hit our waterfall. So for our quick clarity and closure, your 3 important things and your most important thing. And as our answers are coming in, let's scroll through the chat and give some of our colleagues a reaction. So we've got observing phenomena, patterns are everywhere, scaffolding is important, scientists, and the difference between how scientists and engineers use patterns, how CER can be related to patterns, pattern scale, empirical data.
And Lark, we have one hand up, initials WO.
Oh, thank you.
Sorry, that was my mistake.
Okay, all good. Some ideas about how learning builds on itself, patterns in each grade band, and they increase in complexity. All right, thank you all so much for sharing your ideas in the chat.